One final thing we want to address as we talk about limits is this distinction between regular limits that we've already been talking about and what are called right and left-hand limits. So first up, consider the notation here: limit x approaches c followed by a little minus sign of f of x equals L. That little minus sign is indicating that we only want to look at values that are smaller than c, that are below c. So that's referred to as the left-hand limit. Left-hand limit, taking values that are below c. And so if we have a graph of some function here, when we're approaching c here, we're only looking at the stuff that's below c. We don't care about what happens. We don't even have to have a function up above c for that matter. I mean, the graph could just stop there. Left-hand limit is only worried about what happens below. What happens below. It's no interest in anything above. And again, the notation is a little minus sign. Now, if you have a graph like this one where you know that the overall limit is L, then the left hand or the right hand would have to also be L. The other notation is limit x approaches c followed by a little plus sign of f of x. That is the notation for values above c only, or what's called the right-hand limit. The right-hand limit. So it's only interested in what's happening above c. What's going on below c may as well not even exist as far as the right-hand limit is concerned. So here's an example. This is a piecewise function. As we approach c, we're only interested in those values that are bigger than c. So all this stuff over here doesn't matter as far as the right-hand limit is concerned. We just scratch it all out and erase it. So as we are approaching c from above, then it's settling in towards this number here, L. It's settling in towards this number, L. The left-hand limit is going to a completely different value. And the overall limit isn't approaching anything. The overall limit does not exist. So again, if the full-blown limit exists, then the right and left will be the same. But if the right and left are not the same, then the full-blown limit won't exist. In fact, we can state this as a fact here. Limit as x approaches c of f of x approaches L. IFF is the abbreviation for if and only if, the biconditional. If and only if the left-hand limit is equal to L. So full-blown limit is equal to L if and only if the left is equal to L and the right is equal to L. Okay, if and only if. So that means if you have a full-blown limit approaching L, then both sides have to also approach that. And the other side of the coin is if both sides approach L, then the full-blown limit approaches L as well. The contrapositive of that is if the right and left don't agree, then we don't have an overall full-blown limit. So we're already seeing these notations come up. You may see them in some of your graphical or numerical problems. If you're doing a numerical table for a left or right, we're only doing half the table. We only look at values on one side of the limit value, the limit we're approaching, the numerical value we're approaching. Graphically, again, you just look at that side, left or right-hand side. Okay, so we're going to see these notations come up again later on in some other examples. But for now, I just wanted to kind of roughly describe what they are.